Hundreds of organizations rely on Citrix XenDesktop to give users in offshore locations access to applications and data that reside in data centers in Australia in places like Sydney and Melbourne. In this demonstration, we'll simulate the experience of a user based in India accessing applications in Australia. The network round-trip time between India and Australia is approximately 400 milliseconds. Such high round-trip times make the XenDesktop user experience particularly susceptible to network problems such as congestion, which will result in a laggy, unresponsive session. In this demonstration, we'll show how NetScaler SDWAN Optimisation overcomes this problem and protects the user experience even under adverse network conditions. Let's start by looking at the experience without optimization. To do this, we've set up two identical PCs with a wide area network emulator. We can confirm this is working with the 400 millisecond round-trip time shown by the ping command on the screen. We'll now test the responsiveness of the Citrix receiver session. As we type on the screen, the characters appear very quickly. We can move windows, maximize and minimize windows, and whilst there's a little bit of lag that we can perceive, it's still quite okay for an interactive session. Now we'll create some network congestion. For the sake of simplicity, we'll do this by copying a moderate-sized file from the hard disk of the local machine up to the virtual desktop through the Citrix session. This has the effect of creating network contention and congestion as the bulk data transfer of the file from the local hard disk up to the virtual desktop competes for bandwidth with the pixels being displayed from the server to the client and for the mouse movements and keystrokes that are being transmitted from the client back to the server. We see the result of this when we attempt to type something on the screen. The amount of delay between the keystrokes and the characters actually appearing on the screen is completely excruciating. And then when we attempt to click and drag on a window and move a window within the screen, it's so laggy that we simply can't do it in a coordinated fashion. It's quite clear that at this point, the session has become so unresponsive that it's impossible to continue working until the bulk data transfer has completed. Bear in mind that in this test, we're generating the traffic from the same client on which we're testing the user experience. In practice, this traffic could be caused by any other device on the network. It may be another Citrix session where somebody's initiated a print job or a file copy, or it could be completely unrelated to the virtual desktop traffic. Let's leave that session running and look at the optimized experience instead. We have the same spec client PC, and as you can see, same 400 millisecond round-trip time between the PC and the server. The baseline experience is the same. Typing is fairly responsive, there's a slight lag when we move windows around, but essentially there's not much difference at the moment because we don't have network congestion to cause a problem. Let's now go ahead and create that network congestion exactly the same way, copying the same file from the local hard disk up to the virtual desktop. When we test the responsiveness of the machine at the optimized site, we immediately see a massive difference in comparison to the site without optimization. There's no noticeable delay between keystrokes and characters appearing on screen. We can still click and drag windows around, and basically we can just carry on working as normal. Compared to the non-optimized site, where this type of network congestion brings a virtual desktop session to a halt. Not only does the interactive session perform better with optimization, but the bulk data transfer accelerates as well. And we'll see that at the optimized site, the entire transfer takes around about a minute. The problem in our test scenario is that the network can only see one type of traffic, a Citrix session, and it can't tell the difference between the packets within that session that belong to the bulk data transfer and the real-time packets that relate to pixels appearing on the screen or to keystrokes and mouse movements moving back to the server. This is where NetScaler SDWAN Optimisation comes into play. Because it's made by Citrix, it's able to decode the Citrix session and to separate the different types of traffic between real-time and bulk data transfer. This way, it can deliver the most responsive, best quality interactive user experience while accelerating bulk data transfer and making the most of the limited bandwidth of the WAN link, effectively enabling us to get more Citrix sessions down the same link or to allow the same link to be shared between the Citrix sessions and other applications.